All right, so we shall begin looking at the atomic structure, which I believe is a basic foundation of chemistry. So for us to understand everything that we're going to be dealing with in chemistry, we should be able to get a better understanding. So I will record this video, this lesson in full to your understanding. If any question arises, kindly inbox me, kindly contact me on my WhatsApp, even direct calls. All right, so we shall start looking at the atomic structure. Okay, so atomic structure, there are things that you need to know. Number one, you have to know the definition. Okay, so definition, by definition, you said an atom. An atom, one of the definitions you gave, you said is simply is smallest particle of an element. Okay, that takes part in a chemical reaction. Okay, or you can say this is the basic building what? Basic building block of matter. All right, so you said an atom is simply the smallest particle of an element that can take part in a chemical reaction. So RXION, this word here is simply the shortcut form. This word here, this is just simply the shortcut for reaction. Okay, so definition say this is the smallest particle of an element that can take part in a chemical reaction. Or if you forget that one, we can use the one we did in grade, should be in junior secondary, where we said it's a basic building block of matter. It's a basic building block of what? Basic building block of matter. So now from here, there are things that we have to understand. So this atom, it has three fundamental particles. Okay, so what do we mean? So in this atom, we say there are three major things that are found in an atom. And these three things, we have to discuss them. We cannot run away from them. So what are those three things that are contained in an atom? So number one, so in an atom, we have got electrons. Okay, we have got protons. In this atom, we have the neutrons. Okay, so these three are the basic fundamental particles that are found in an atom. So we said by definition, an atom is simply what? The smallest particle of an element that can take part in a chemical reaction. If we don't want to define it like that, we can simply say it's a basic building block of matter. Then after we discussed the definition, we have to look at the three fundamental particles of matter. Now, what are these three fundamental particles? So it's more like we are looking at in a house. In a house, there are different rooms, or there are different things that are found in a house. So amongst these things, we have a kitchen, a bedroom for we have bedrooms, we have the sitting room. So even in an atom, there are different places, and then there are also different things that stay in an atom. So amongst the things that stay in an atom, we are only discussing 3 of them, and we call them the fundamental particles. Of course, there are a lot of them, but now we are looking at those fundamental. This can also mean the most important, okay? The most important things that are found in an atom. So we say we have electrons, protons, and the neutrons. So after the scientists had sat together to see how this atom behaves. So an atom is in an orbit. So now since it's in an orbit, it has got different places. So in an atom, there is what we call the nucleus. Okay, there's a nucleus. Then in an atom, there's what we call the shell, or we call them the orbitals. Okay, this shell, a shell, we know to say it is all right. So we're saying in the nucleus. So we said an atom has these two special places. It has got the inside part, which we are calling the nucleus, and the outside part, which we are calling the shell, which can also be called the orbital. Now we know to say a shell, if we take an example of an egg. So what is found outside there, we call it a shell, the shell of an egg. Okay, so the shell simply it's found outside. Then orbital. So this means that this shell, it is a concentric ring, a concentric ring. So meaning it is a round like thing like that. Okay, it is a round like thing like that. So now this orbital means it orbits. To orbit is it's to go like that, to to move around. Okay, to move around. So this orbital simply means this thing is concentric and it moves around. Okay, it moves around in a direction like that. So we have two places, the nucleus and the shell. So let's look at the positions. Let's look at the positions of which these atoms, this atom arranges itself. All right, so these questions are very simple, but if you don't have the perfect foundation for atomic structure, it's going to be a little bit, if not tough, it's going to be okay. So we look at the structure, okay, the structure of an atom. The structure of an atom. All right, so we said a structure of an atom has got two major places. So we shall have that as our first place. Then we are also going to have that okay, so now we say we have this part and these. Okay, so we have this first part. So this thing found at the middle there, at the center, this is what we call the nucleus. So we call that part the nucleus. The nucleus. Okay, we call that part the nucleus. Then these circles around the nucleus, this is what we calling what? The shells. The shells or the orbitals. Or we call them, in other words, that energy levels. Okay, so we have the center there, which is called the nucleus, and then we have got these rings, these circles around, which are calling the shells, orbitals, or the energy levels. So now, after we look at this, we are going to go back to the three fundamental particles. So we said we have three fundamental particles of this so-called atom. So three fundamental particles. So these three fundamental particles, number one, we said we have the electrons. Number two, we said we have the neutrons, yeah. Then we have the protons. Okay. So now, these three fundamental particles, where are they found in this structure? So when you look at the electrons, we say they are found in the shell. Okay, so electrons are found in the shell. The neutrons, they are found in the nucleus. Then the protons, they are found in the nucleus. All right. So we are going to draw another diagram to show that these three fundamental particles, they are actually found in a specific place or in the structure of an atom. So let's have that. So let's call this our nucleus. So now we are saying in this our nucleus, we found the neutrons and the protons. Then around this nucleus, you have the shells. So in this shell, this is where you find the electrons. Okay. This is where you find the electrons. This is where you find the electrons. So we are saying we have a structure of an atom which has two places. These two places are accommodated by the three fundamental particles. Now, where are each of these three fundamental particles located? So we've just looked at an electron, which is found around in those rings. Okay, so we're saying electrons are found in the rings, then the neutrons, together with the protons, they are found right in the nucleus there. They are found in the nucleus. Okay, they are found in the middle there. So now this is about the three fundamental particles. So we have talked about electrons being found in the shell, neutrons being found in the nucleus, the protons being found in the nucleus. Now what about their charge? What about their charge? So we have looked at the first thing to say where are these three fundamental particles located. So we have established where they are located. We have seen that electrons in the shell, the neutrons and the protons in the nucleus. So now we look at their charges. Okay, so charge. When you talk about charge, we talk about either being positive, being negative, or it doesn't have positive, not even negative. So meaning it has zero charge. So now, for electrons we say they are negatively charged. Then the protons, they are positively charged. Then the neutrons, they have zero charge. They are neutral from the word neutral. Neutrons. So electrons are negatively charged, protons, they are positively charged, and the neutrons, they are zero charge. Okay. So now an interesting question would come here. But before we look at that particular question, let's look at one last thing. Right. Right. So we are going to say electrons. We have said electrons, these they are found in the shell, and they have what? They have a negative charge. Then the protons, they are found in the nucleus, and they have a positive charge. All right. So we are now going to look at what we call the nuclide notation. Nuclide notation. So now, this nuclide notation takes a symbol that X. So this X means this can be any element. Okay, so any element. Where do we find these elements? These elements are found on the periodic table. Periodic table. So now, these elements, since they are found on the periodic table, we have got a lot of them. So this X can mean any of those elements on the periodic table. So when you go on those numbers on the periodic table, we have a number found down there and the number found on top there. So you have this element and the number on top and the number which is down. So this number on top here, it simply represents what you call the nucleon number. The nucleon number. We can also call this nucleon number as the mass number. Okay, then this number which is down, it is called the proton or atomic number. So now we have this element which has got a number on top and also a number down. Okay. All right. So let's quickly look at all right, so let's go over. So now if we go on the periodic table, we check on hydrogen. Okay, hydrogen. It has got a number 1 there and the number 1 on top and also down 1. So this number on top here, this is what we call in the mass or the nucleon number. You can confirm that. Then this number down here, this is what we're calling the atomic or the proton number. If we check for sodium, which is that, so it has got those numbers. This is the mass or the nucleon number. Then this is the proton or the atomic number. Now let's look at an example here where okay, so we are going to say notations. So if we look at the number of protons, so proton or atomic number, this has got a symbol of Z. Then the neutron number has got a symbol of that. Then the mass or nucleon number has a symbol of A. Now, if we go on the nuclide notation that we had, X right. So to continue from where we ended, sorry, the 35 minutes duration for this meeting was cut. So we continue from there. So now if we were just saying that we have discussed to say on the nuclide notation we have the atomic or the proton number, which uses the symbol Z. We also have the mass or nucleon number, which uses the letter A. That's a symbol A. Then we are going to also have the neutron number. So this one, it is going to have symbol N. Now, the thing is, if we get back to our notation, we said if this is B and this is A, so this X, it means any element on the periodic table. Then this B means a number which is found on top of it, and then this A means the number that is found down. Okay. That is found, the number found down that particular element. Then we said this is the mass of the nucleon. Then we said this is the atomic or the proton. Now, we can't see anything related to the neutron number. So now, if there is no neutron number on this notation, this now takes us to a most important formula that we're going to be using throughout. So we're going to say A is equal to Z plus N. This formula will be very important throughout our calculations under this particular topic. So now, this means that for us to get the mass number, we have to add the number of protons plus the number of the neutrons. Okay? So now, this is a relationship. We say the mass number is equivalent to the summation of the proton and the neutron number. So now let's quickly look at aluminium. Okay, so if we check for aluminium on the periodic table, it's written as AL 2713. Then this element, they will ask you to find the mass number. They'll ask you to find the proton number. They'll ask you to find the neutron number. Okay, so now this is the thing. Mass number, we said the mass number, if we go to this, our notation, we said this number which is found on top there, this is the mass number. So we're just going to get this number here and write it there, 27. Okay, then for us to get the proton number, we said proton number is just this number found down here, which is that we are going to write it there, 13. Now, for us to get the neutron number, because we don't have neutron number there, we are going to use this formula. Okay, so we have the mass number, we have the proton number, we just don't have that. So for this one, we are going to use the formula to get that. So you are going to say A plus A is equal to Z plus N. So now you can make N the subject of the formula since you are finding for N. So I'm going to say A, when you bring this one to this side, it becomes A minus Z is equal to N. So what is your A? Your A you got as 27. Minus what is your Z? Your Z you got as 13 equal to N. So 27 minus 13 is 14. So you say 14 equal to N. So now get this number and put it there. So it gives you 14. Okay. So that is how we find the number of atoms, the number of the mass number, proton, and the neutron number. Now, a question will not come as simple as that. Okay, they'll ask you to say, they'll ask you something like, okay, sulfur has an atomic number of 16 and a nucleon number of 32. Find the neutron number. Okay, so here when you get your data, you find that atomic number, they've given you the atomic number. Atomic number has got symbol what? Atomic number has got symbol Z. So your Z is 16. Then a nuclear number of 32. So nuclear number, we said it's the same as mass number. So it has got a mass number. Mass number is represented by A. So you say A is equal to 32. Then they're asking of the neutron number. Neutron number is N. So the same thing we did here. We're going to say A is equal to Z plus N. A minus Z equal to N. Your A is 32. Your Z is 16. So your N is 16. As simple as that. Now quickly, let's go over a step. We add some icing sugar to our cake. Okay, so now let's look at what we call ions. Ions. Okay, so by definition, ions are simply charged particles. Okay, charged particles. An ion is a charged particle. Then you say types of ions. So there are two types of ions. There are two types of ions. Number one, ions can be um, okay. So an ion can be positive or it can be negative. So we have got what you call the cation ions. Then the other type of ions that we have, these are anions. Right. So these are the two types of ions that we have. Now, so we are going to say cations, these are positively charged ions. Okay. Then the anions, these are negatively charged ions. Okay. So we are talking about ions, which we are saying these are charged particles, and then we have two types of charges. These two types of charges are negative and positive. Okay, so now we are calling the positively charged ions as the cations, then the negatively charged ions as the anions. All right, so let's look at something um something very interesting here.